Welcome back, cyberscripters. In this session of Python learning, we would look at how to extend Python built-in data types like string, list, dictionary. Now, why would you want to do it? Let's say you have a specific requirement and you want to add specific functionality to the data type. If you talk about list, you want to create a list data type which accepts only integers. Or even going further, your list accepts only even integers. Or whatever is passed to my list, even if it is a integer, I want to convert it to string and store only strings. So it depends on your requirement, but you should know how to add functionality to existing the built-in data types and extend it. So let's get started. So we'll create one Python file. Let's name it as extended data types. We will take example of a list. So let's create our extended class. We'll name it extended list and it would extend list. So the benefit of this is all the methods and attributes that are available in list class would be available to our extended list as well. Now let's write our constructor underscore init, and our constructor would take one iterable. So simply what we would do here is we would call parents constructor using super method. So we'll call super dot init and we'll pass that iterable, that is passed to this constructor. Let's just go ahead and test it. Let's say I say 1 comma 2 comma 3 and let's print it just to make sure that everything is fine. 1 and there is our list. So nothing fancy till now. We have just created our class extending list and we have called the constructor, the parent class. Now let's define two more methods which are primarily used on list, that is extend and append. So let's say append, and here also we don't want to do anything for now. We'll just call append method of parent. Same for extend. So again, nothing fancy, just the usual stuff. Let's just test. So I will say e dot append. Let me append 4. Let us again print e, and let us use extend as well. And I want to extend it using list 01, 102. Then let's print it again. So now let's go ahead and test it. Okay, sorry. Super, and then it has to be extend. Okay, so this is what we want. This is our original list. We appended 4 and then we extended by this list. So everything is working fine till now. But this is of no use, right? This is just a normal list. Now we want to do is we want to add a filter method that would filter whatever value is coming to this list and would take a decision, right? So we'll call it underscore validate. So this method is going to validate whatever is passed to it. Okay. Now let's say for now we want to create a list that stores only integer values. So what we say is if is instance value comma integer, then return true, right? Now, what we have to do is, next step is when you create this list using constructor, we are not checking anything here. So once this is done, what we would do is we would create a copy of the list. So self.copy. Remember, self is a list. So we have copied it. Now we'll just iterate it. So for item in C, right? If self dot underscore validate item, right? Let's say not. Then what we want to do is we want to do self dot remove item. So what exactly we are doing here? See, we are iterating this list and we are calling this validate method for every item. And if it return false, we are just removing that item from the list. Okay, now let's just check it. So while doing constructor, if I say 6.0 a float and maybe a in string and then let's say 50. Let's see what we get. See, what we are getting is only integers. So we got 1, 2, 3. This was not added. ABC was not added, and directly 50 was added. So constructor is working fine. So whenever you call the constructor and pass down your numbers, it will check if they are not integer, it would simply won't add it to your list. Now let's look at append method. Now in case of append method also we have to add that check. So we say if self dot underscore validate underscore object, then only we want to call this append method. If not, we don't want to call it. Let's just test our append as well. So if I say here test, it should not append it to the list. See, this list is still showing 1, 2, 3, and 50 only. Now look at extend. Now, append was easy, but then in case of extend, you can get a list as well. So here, what we'll do is we'll check first if the past iterable is object of extended list or not. So I will call if is instance iterable is of type self. So what we are checking here is if the object passed for extension is of the same type, then I don't need to check anything, right? It is of same type, so it only has integers. So we can just go ahead and add this part. If not, right? Then what we have to do is we have to do for item in underscore iterable, we'll check each item. If self dot underscore validate this item, then we have to call super dot append and we call underscore iterable. Right? So basically what we are doing is before calling extend or append of the super, we are just calling our validate method to make sure that the object is as per our rules. And if that is the case, then only we want to add it. Let's see if this thing is working fine. Okay. So here we made a mistake. We don't have to append iterable, but we have to append item. So okay. Now it is working fine. Let's try to see if we can add float or string to our list. It's not So this works, but still it is not as useful. Reason being, for every kind of extended list, you will have to write a new class, right? So I want to store only integers, I have to write a new class because this particular validate method is embedded into the class. So let's write a better version of this wherein user can pass his own validate method so that we don't have to write this class again and again for our different purposes. So what we'll do is let's add a validator. So for now what we will do is we want user to pass this function. So user will have to write a validator function and we'll have to pass to our class. But for default, let's write a lambda x colon x. So what it simply says is whatever you give to this validator, it would return the same thing. That's it, right? So actually is of no use because we want user to pass this validator. Now let's write a validator function. So remember this is outside the class. So what I say is v value if is instance value comma integer. If this is integer, then let's make a small change that we want to create a list, but that list should store only integers and that too if it is even. So we say if value mod 2 is equal to 0, then return true or return false. So this is our validator. Let's pass the validator here. Right. So what we are doing is we are passing our iterable and then we are passing a function that would actually be called to validate. Now what happens? See. Now what we do is we don't call this. Let's create one self dot validator is equal to validator. Right. Now we won't call self dot validate, but we'll call self dot validator. Now remember, this validator has function that is passed by the user, right? So same here. Again here as well. Now let's see what happens. See, we have got only even numbers. So what is happening? Now we don't need this validate method. Let's just comment it. So what is happening now? So now the user who is creating object of your class can decide what kind of list you want, right? Now, if I say instead of this, if I write one more validator, let's write v1. So def v1 is equal to let's say value, right? If is instance value comma str, then return true. Now it's return false. Now what happens? See, now I say my validator is v1. I'm getting only strings. So what is happening here is according to the validator that is passed by the creator of this object would decide how your extended list is going to behave. Now this is really important. This is very helpful now. See, our earlier version was not that helpful because the validator was inside the class. Now what we have done is we have created a validator that can be passed to our class. So now this gives a lot of freedom to the user, and he can create as many kind of list objects as you want, and this is really helpful. You can also extend this using, you can add one more function like I would say converter is equal to again lambda x colon x. Now what is this converter? So what we were basically saying is whatever is passed to us, we want to store only strings, right? So I want to create a list that stores only strings. So I would say C value, right? If is instance value comma str, then return value. Else return string of value, right? Now what we got to do is here we don't pass this iterable right away. What we do is we say item for item in iterable. Let's just pass this item to our converter. See now what happens. I'm not passing any validator. I'm just passing converter. See, everything is stored as string. So what is happening here is basically what we are doing is we are passing a function, converter function to our list. And what it would do is it would convert whatever value it is getting using that converter function before adding to that list. So for example, your converter function would say if this is integer, then return, let's say I want to store square of all the integers that are returned to me. So I can say value into 2, and maybe value star 2. Else, we'll just return false. So what is happening now? The number are being squared, right? And here we can say, so basically, if you use combination of converter and validator, you can remove this as well. You can just pass your validator saying if it is integer, then return false, and it would all get removed. So basically, the idea is it is very useful. So when you are writing your code, if you know how to extend your built-in data types, that can really make a lot of difference. And you can create your own data types and you can use them. So try doing this. And if you have any comments or queries, just drop in the comment section and I'll get back to you. Thank you.